Hey students, just to recap on the previous video, we talked about oxidation reduction reactions or redox reactions. We went over briefly what is an oxidation reaction? It's a loss of electrons, right? In the case of A, losing an electron, and B is gaining it. And we call what happens with B a reduction. Even though it's sort of gaining it, it's reducing in terms of its charge because it's gaining a negative electron. So the more electrons you add or gain, the more negative you're going to be, as we see in the left-hand side here. So how are we going to remember this? That oxidation means that you're going to lose electrons, and reduction is gaining of electrons. There's a really helpful mnemonic device, and it's oil rig. An oil rig is a mnemonic device that's been used for many, many years to help remember this. And I still remember from my high school years. It means oxidation is losing and reduction is gaining, right? Really helpful to remember when you're doing some more of the harder problems to remember this. We then moved into an example of sodium chloride and going through the process and writing the half reactions for the sodium being oxidized and the chlorine being reduced. And we saw that we write the electron for oxidization on the right-hand side, indicating that it's separated from the oxidized substance. And on the half reaction for reduced substances, we write the electron on the left-hand side because it's being added to it. And on the right of that, you don't see it because it's incorporated into that substance already. And that's just the sort of final redox reaction again, where we label NaNCl as oxidized and reduced, respectively. So the reason why I recapped is because it's a good segue into something called the agents, oxidizing agents and reducing agents. So in this video, I really want to focus on this concept, this idea that there are agents as well. And an agent, if you can remember this, agent is just a term we use that is a substance that makes something happen. So in the case of an oxidizing agent, it makes oxidation happen. And in the case of a reducing agent, it makes reduction happen. So let's go back here for a second. And what I want to do is just remind you of this A and B here. Remember that A is being oxidized. And the reason why I know that is because it's losing electrons. And remember, oil rig, right? Oxidation is losing electrons, OIL. So it's losing electrons, right? And in this case, B then is reduced because it is gaining electrons. Now, one of the things you know and you understand now is that with a redox reaction, you can't have just oxidation or just reduction. Something can't gain electrons without them coming from something else. And conversely, you can't just lose electrons and them to go nowhere and just disappear. They go to some other substance. So you need both of them. And so the thing that is oxidized is the reducing agent. What does that mean? What does that specifically mean? Well, what that means is that A, in this case, is being oxidized, but it is helping or giving electrons to the oxidized substance. In this case, it's B. I'm sorry. I apologize. I should backtrack for a second. It's giving electrons to the reduced substance. Apologies for that. It's giving it to B, right? And the reason why we call it the reducing agent, right, is because it's helping B to be reduced. How? By giving it electrons to help it be reduced. Okay? So we call that the reducing agent. And conversely, the reduced substance, in this case B, is taking electrons from the oxidized substance. So it's making oxidation happen by taking the electrons from A. So that's why we call the reduced substance B the oxidized agent. And just to remember, the thing that's being oxidized, in this case B, or A, is the reducing agent. And the thing that is being reduced, in this case B, is the oxidizing agent. Okay? It's always that way. Hope that was helpful.